The immediate physical consequences of an industrial fire represent a massive failure of facility integrity. These events present an active threat to the surrounding environment and local infrastructure that can rapidly scale beyond control. Left uncontained, the fire eventually causes total structural collapse and the total loss of the facility. Mines, grain elevators, refineries, and chemical plants represent the 4 industrial sectors most susceptible to these catastrophic events. This chart shows how fire fatalities in these 4 specific industries alone dwarf the combined total of all other industrial sectors. This concentration of danger stems from the extreme daily volumes of highly flammable and combustible materials processed within these facilities. Industrial fires operate outside the realm of unpredictable acts of nature or unavoidable accidents. These disasters occur as the predictable outcome of specific chemical reactions that precede the moment physical safeguards fail. A facility's survival depends on 2 distinct operational frameworks: the Proactive Fire Prevention Plan, or FPP, and the Reactive Emergency Action Plan, the EAP. Protecting a high-risk facility requires treating fire as a strictly governed engineering problem, demanding continuous administrative control and environmental oversight. Industrial fire safety protocols are governed by a scientific model known as the fire triangle. It identifies 3 elements required to create a fire: oxygen, a heat source, and fuel. A sustained flame requires these to continuously combine in a rapid chemical reaction. Industrial fire protection focuses entirely on preventing this specific chemical reaction from completing. To halt the process, engineers must permanently isolate or eliminate at least one of these 3 variables. Since oxygen cannot be removed from most working environments, safety protocols focus on controlling the fuel and the heat sources. The fire prevention plan serves as the large-scale architectural and procedural strategy to ensure that fuel and heat remain separated. In an industrial setting, the fuel variable often takes forms more complex than a simple liquid or pressurized gas. Ordinary workspaces become volatile environments when they facilitate unexpected chemical reactions. Combustible dust is one such environmental hazard, as seen in the catastrophic Imperial Sugar Refinery disaster in Port Wentworth, Georgia. Materials like sugar, grain, and metal shavings, while benign in bulk, become highly explosive under the right conditions. A dust explosion occurs when particulate matter becomes airborne, rapidly expanding and filling an enclosed volume of industrial space. Suspending these particles in the air drastically increases their total surface area, exposing the entire volume to oxygen simultaneously. This airborne suspension transforms a workspace into a facility-wide fuel source, primed for a single microscopic spark. Housekeeping acts as the primary, legally mandated engineered control to mitigate this specific risk. Rigorous housekeeping minimizes the accumulation of airborne combustible dust before it reaches a critical explosive threshold. Controlling the fuel variable necessitates managing invisible environmental factors alongside the oversight of bulk storage tanks. We turn next to the ignition node of the fire triangle, the heat sources that trigger combustion. Facilities must monitor visible ignition threats, like open flames, hot machinery, and overheated bearings. Static electricity remains an insidious and difficult-to-track threat, particularly during the transfer of industrial fluids. Static electricity builds up through microscopic friction when dispensing flammables like gasoline or diesel through pipes, creating a hidden hazard. Engineers neutralize this electrical threat through 2 physical controls: bonding and grounding. Bonding involves connecting 2 conductive objects with a wire to equalize electrical potential. Grounding connects that bonded system directly to the earth, safely dissipating the charge away from the fuel. Proper bonding and grounding removes the invisible heat variable from the equation, ensuring the fire triangle remains broken during fluid transfer. Mechanical systems can fail despite rigorous controls. When these failures occur, the fire triangle completes. The moment the fire prevention plan is compromised, the emergency action plan, the EAP, is immediately triggered. To contrast these systems, the FPP engineers the physical environment to prevent a fire, while the EAP engineers human behavior to survive one. The immediate priority of an EAP is executing rigid, pre-planned evacuation procedures along clear emergency escape routes. Safe, geographically isolated assembly areas are designated outside the hazard zone to receive evacuees. Managers then execute an accurate headcount to account for every employee at the assembly area. The plan also details complex procedures for safely shutting down critical or hazardous machinery prior to a full evacuation. While the FPP focuses on building integrity, a well-executed EAP prevents a structural failure from escalating into a massive loss of life. Facilities utilize active suppression layers during an emergency, including portable extinguishers and fixed extinguishing systems. This matrix chart defines the classification system for extinguishers. These tools are uniquely calibrated for specific fuel types, ranging from Class 1 solids to Class 4 combustible metals. Automatic sprinkler systems, standpipes, and hose systems serve as the final fixed environmental defenses built into the architecture. Specialized teams of employees, known as fire brigades, may also be designated to fight interior structural fires. These brigades must meet rigorous regulatory requirements, including quarterly training and the use of specialized respirators and fire-resistant clothing. Catastrophic industrial fires are combated through a dual architecture of proactive engineering and reactive logistics. Survival requires layering the strict physics of the fire prevention plan with the precise human logistics of the emergency action plan. This strategy breaks the fire triangle before it forms and outmaneuvers it when it does.